All right, this is, I think, video number 4 now on the review for test number 3, Fall 15 for Math 110. I'm looking at the problem number 5 from homework number 9. So this one is a word problem that's applying our linear equations. So it says in August, my bank charged me $8.75 for writing 15 checks, and in September, the charge for 20 checks was $9. Consider the charge for my checking privileges to be C and the number of checks to be N. So I've kind of jotted down some information here. The $8.75 to write 15 checks, and $9 to write 20 checks, and C means charge and N means number of checks. Now, the thing that I really need to get straight in my mind here is that if this is a linear scenario, then I need to know that which one's independent and which one's dependent. So just kind of thinking about this in terms of what I know in the real world is that the money that I get charged depends upon how many checks I write, not the other way around. I don't get a charge, I don't have to pay money and then that is going to tell me how many checks I write. I write the checks and then they charge me money. So the checks are going to be the independent variable here. So this is my independent, and then the charge would be the dependent. So when I go to make this model, I'm going to have C is equal to M times my N plus my B, right? Where this is my slope and this is my y-intercept. Okay, so now thinking along those lines, I'm going to have independence N's and dependence C's in terms of ordered pairs. So this information that they've given me, the $8.75 to write 15 checks, that's actually an ordered pair. So the N's is number of checks, 15 checks, and $8.75, that's an ordered pair. And then 9 to write 20 checks, well, that's another ordered pair. So number of checks, 20, and then $9, that's my dependent. So there we go, that's the independent. That's two ordered pairs. And if I need to create a model, I can use two ordered pairs to create the slope. So let me go ahead and do that. So M is equal to my y's, so that's 9 minus 875, and that's over 9's x value, which was 20, minus 875's, which was 15. So this is going to be 0.25 divided by 5. And so that's going to be 0.05. So that's the 0.05. Let's see, the independent, or the dependence in the numerator. So dependence, those are charges. Charges are in dollars. So this is going to be unit-wise, dollars per, and independent, those are numbers of checks. So dollars per check. And the way that it's written right now as a decimal, that's a unit rate. So that says I have $0.05 per check. Oh, 5 cents per check. That's what that means. Okay, great. And now I have to find that y-intercept, but I don't know how much is charged for 0 checks, so I don't know the y-intercept. So what I have to do here is I have to go and I have to figure out what the y-intercept is. That's what my point slope form is all about. So I'm going to do that down here because I'm kind of out of room. So y minus, and then I have to have my y1, so I can choose either one of these. I'm going to use this ordered pair. So my y is my dependent, which is 9, and that's equal to my slope, that's 0.05, and then my x minus my independent, and that was 20 in the 9 case. And now I'm going to distribute, so I have y minus 9 is equal to 0.05 x, and then 5 times 20 is 100, and then I've got the 2 decimals, so that's 1 right there, right? So 20 times 5, that's 0, and 10, so that's 100, and then 2 decimals. Yeah, I got that right. All right, now I'll go ahead and I'll add 9 in here. And so I have -1 plus 9, and remember that's 9.00. So this is going to look like y equals 0.05x and then plus, and that would be 8. And that is my model. Now, I kind of want to write it the correct way, right? So I'm going to go ahead and I'm going to erase out m, and I'm going to replace it with the m that I just calculated. So my m that I just calculated was 0.05. And there we go for that. And then the b, I'm going to erase out the b here. And I'm going to put the b in as the 8 that I just calculated. And so now I have my model, and it's written correctly. Now it says that we need to use the model to find the charge for writing 50 checks. Okay, 50 checks, that's finding an independent value, or that is an independent value, and it's finding the charge for that independent. So this is finding C with 50, right? So this says 0.05 times 50, and then plus, and then 8. So 50 times 5, well, 5 times 5 is 25 with an extra 0, and then 2 decimals, so that's 250, and then plus 8, and so what I have is $10.50, and I need to put the dollars. So the charge to write 50 checks is $10.50. Now, does that kind of make sense? Well, to write 20 checks, it was $9, and that's more expensive than that. And I know it's not doubling or anything because it's only going up $5 or 5 cents per check, so that seems about right. Now the last question in here asks me to interpret the y-intercept and find it. Well, the y-intercept is $8. So remember, that's what I found right here. So $8, and this means, and so I have to think about this. Well, it's $8, and that means it's the amount of money when I have 0 checks, right? So means the charge for writing 0 checks. So that's basically just the flat fee that the bank's going to charge me for writing checks. So there we go. That's my answer. $8 means the charge for 0 checks. And that's my y-intercept. All right, moving on. The next thing that I want to do is problem number 5. So, oops, no, 5 I did, and so problem number 6. So we're just going to go down and move to this bottom one. So this is a 2-part problem, and we have this general function g of t, and this says I'm going to replace the t with this complicated thing. So this is t equals, and it's this expression, 3m minus 4. That's what that says. So this says 2 times t, which is complicated now, 3m minus 4, and then subtract 5. So you see the only thing I did was I put in that value for t. And now I'm going to distribute and simplify. So 2 times 3, which is 6m, and then minus 2 times 4, which is 8, minus 8. Now these can get together, so this is going to look like 6m minus 13. And there's my simplified expression. Now the second half of this problem again says I'm going to replace g of t with 19. So this gets replaced with 19. Oh, well that looks like solving, doesn't it? So 19 is equal to 2t minus 5. So I'm going to add 5, and 19 and 5 makes 24. And that equals 2t, and then I'll solve for t by dividing by 2, and that tells me that t is equal to, oops, that didn't look very good, t is equal to 12. So that's the value of t to give me the value of the function being 19. All right, moving on to our next problem, one more problem from homework number 10. Okay, and this will be our last problem to go over. Yep, our last problem. So homework number 10. Where is it? There it is. And homework number 10, we're just going to do number 1, and there's 2 problems here. So this is a linear inequality problem, and we're going to solve it, graph it, and give it an interval notation. So first off, I'm going to do just like I would with an equation, and I'm going to simplify. So this is going to be -5 minus 2 minus 4x, and that's greater than 13. Then I want to get these guys together, so -7 minus 4x is greater than 13. And then I want to add the 7 because I need to get it to go away from the x's. And this is going to give me that -4 is greater than, and 13 and 7 is 20. And now I'm going to divide by a -4. And this, remember, this is a big deal. This division by a -4, right, has to reverse the sense of the inequality. So this is going to make it look like x is less than a -5. So graphing this thing, here's my graph, and here's my 0. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now my end point, -5, so I locate that. And it's not included, so I'm going to use a scoopy on it. And you could also, remember, use an open circle, but I'm going to use the scoop. And then it's less than this in standard form, so that means it's pointing that way. So this is going off that way. Don't forget, put it right on the line. Use a pencil to draw the line, use a pen to show it on there. And now interval, this thing's going off to -infinity, and I can't capture it, so parenthesis, comma, and then this is a -5, and it's not captured either, so parenthesis. And I'm going to make this look more like a parenthesis because I don't think it looks too much like one right now. So there we go, a little bit scoopier. All right, moving on to the second part of this problem. This one is a compound inequality. And this compound inequality, remember, is actually 2 problems. One problem from here this way, and one problem from here this way. But we can solve them simultaneously. So I'm going to go ahead and do that simultaneously by thinking about what I have to do to get the x alone in the middle. And when I'm getting the x alone in the middle, I need to think about how to undo everything that's done to it. So I would have to subtract 3. Well, that means I subtract 3 over here, and I subtract 3 over here, because remember, there are 2 problems here. So -3 and -9 is -12, and that's less than or equal to 4x. And then 7, oops, that is a needs to be a less than symbol. Less than 7 minus 3, which is 4. And now I need to get the numeric coefficient away, so I'm going to divide by 4, which I have one problem over here to do that, and one problem over here to do that. And so now I have -3 less than or equal to x less than 1. Now sometimes students will think that this one, because I had a negative here, I have to reverse this, but I didn't divide by a negative. I had a negative number, it was a negative number is a negative number. I didn't take any opposites of anything. It was what it was. So now I have to go ahead and I have to graph this. So number line here, and put all my numbers on. So there's my 1 through 5s at least. And now I'm going to locate my endpoints. So my endpoints here, -3 on this side. And remember, this is a standard form of a compound linear inequality because we have small number -3 and large number right, and I read left to right. And these are both less than symbols. So that's in standard form. So all I have to do is locate the left endpoint, locate the right endpoint. The left endpoint over here is equality, so that means it's included. So I'm going to use a bracket on it. And the right endpoint does not have any equality, so it's not included. So I'm just going to make a scoop. And then it's everything that's in between those. And that's my solution. Now my interval notation, left endpoint, tell everybody it's included, comma, up to, right endpoint 1, not included, so it's got a parenthesis on it, and we're all done. All right, that's the end of the review.